Hello smart learners, welcome back to this channel again. So in this video let's estimate the value of pi. Okay, you have learned many types of methods of calculating or estimating the value of pi. So but in this video I am going to show you how to estimate the value of pi using Monte Carlo simulation method, okay, in fortran 90. So in most of my previous videos I have shown you how to use the value of pi. Okay, so here is a fortran file I have created that simply gives you the value of pi. Okay, and it looks like this. Okay, so I think you have remembered this term. Okay, so actually pi is equal to, this is pi, pi, and it gives the value of pi. Okay, 4 times arctan of 1.1. Okay, so how this formula comes is that you may simply know that tan 45 means 1. Okay, or you can simply write tan pi by 4 means, in degree pi means you use 180 degree. Okay, so pi by 4 means 45. Okay, 45 degree, so tan of 45 degree is equal to 1. So if you simplify this term, then you get pi is equal to how, 4 times, or you can simply write pi by, okay, pi divided by 4 is equal to arc tan. Okay, it is 1. Okay, you can simply write it, and so pi is equal to 4 into arc tan of 1. So this formula is used in this code as this form. Okay, because I have used double precision here, so I recommend you to use double precision most of your codes if you estimating value of any constant. Okay, physical constants. So if you compile this file in terminal, let's open the terminal like this. Okay, then you have to just run this program. Okay, and for this simply type j fortran and value. Okay, and it is pi. Okay, I have to use like this. Okay, so this file is this. Okay, let's run it. Okay, why it is not giving value of pi? Okay, let's run it again. So if you want to display the output, the value of pi is this. Okay, this is a direct method, but there are many types of method of calculating, estimating the value of pi. Okay, so one of them is Monte Carlo method. So what is Monte Carlo method? Let's discuss first little bit about the Monte Carlo method and how the algorithm of the Monte Carlo method and formula to use and etc. and conditions. So I have created here a file of calculation. So it says estimation of value of pi by Monte Carlo simulation in fortran 90. Okay, so Monte Carlo method is the method that uses the concept of a random number. Okay, random number. If you don't know about generating random number in the fortran programming language, please click on that I button on your screen and watch the video I have uploaded before. Okay, if you have a small little bit idea about generating a random number, then it's okay. Okay, so let's move further. In Monte Carlo method, what we have to do is we simply consider a square. Okay, like this. You can see the square of purple color, and this square inscribes a circle like this in the green color. Okay, and center of both the circle and the square lies at origin of this coordinate system. uh, Actually it is two-dimensional. Okay, you have to use two-dimensional coordinate system, x along horizontal and y as perpendicular or vertical. Okay, so origin is center of the both circle and square is at O. Okay, so and keep in mind that the sides of or edges of the square and the diameter of the circle all are equal to 1. Okay, 1 unit. Let's suppose 1 unit. Okay, we don't specify units of the length here, so you can only specify it as unit. You can actually use any unit, centimeter, meter, kilometer, or feet, anything. Okay, so to estimate the value of pi by Monte Carlo simulation method in Fortran 90 or any programming language, you should know the theory. So let's discuss the theory first. First of all, consider a square of square. Okay, this is square of side 1 unit, so that the area of the square is 1 unit into 1 unit multiplied by 1 unit is equal to 1 unit square. Okay, so area of the square is this. Okay, and now consider a circle inscribed by the square with the diameter of circle equal to side of the square. So I have shown you the circle in the green color. Okay, whose diameter is also 1 unit, which is equal to side of the square. Okay, so diameter of circle is equal to 1 unit as well, and area of the circle is pi times, as you know, radius, square of the radius. So you can convert the radius in terms of diameter as diameter by 2, because we have value of diameter as 1 unit. So you can just write the radius in terms of diameter as diameter divided by 2 and whole square. Okay, and it gives pi by 4 unit square actually. Okay, I have so you don't need to write unit here. Okay, now you have the value of the square, area of the square, value of square, area of the circle. Okay, now let's find the ratio of the area of circle and area of square. Okay, it is actually pi by 4. Okay, it is actually pi by 4, and you can simply know, because area of square is 1 and area of circle is pi by 4. So area of circle by divided by area of square is simply pi by 4. Okay, so on simplifying this, we get pi is equal to this term multiplied by 4. Okay, so it looks like this. Okay, this is actually the formula we are going to use while calculating value of pi by Monte Carlo method. Actually, you should remember another point here. Actually, the area of circle equals okay, actually this term, okay, this ratio equals number of points inside the circle divided by number of points inside the square. Actually, area of circle is equal to number of points inside the circle. It means you have to consider many points, that is xy. Okay, pair of xy in this area and in this area, whole area of square as well. Okay, so that the ratio of the numbers of points in the circle and in the square is equal to pi by 4. Okay, so you can simply replace this term by this area terms by number of point terms, like this. Okay, and for this, what is the condition for the point of number of points inside the circle? What you have to use the condition is this. Okay, it is x square plus y square is less than or equal to 1. So the distance of the points from the origin. Okay, points means this point xy will be here, here, and this must be less than 1. Okay, less than or equal to 1. So remember this. Okay, it is simple. So this means points should lie inside the circle. Okay, for the number of points inside the circle, this condition should be applied. Okay, now let's discuss the algorithms. Okay, we perform this simulation in fortran 90. Okay, let's discuss the algorithms first to write the fortran code. Okay, so first of all, we initialize the program. Okay, we initialize the program, and we have to, as I have told you, we have to use the concept of random number in case of while using the Monte Carlo method. Okay, to estimate the value of pi. So generate random number x, generate random number y. So we have to generate two types of random number, x and y, because we have used two-dimensional space here, x and y. So actually x and y here are random numbers, and these random numbers should lie between 1 and 0. Okay, and after calculating generating the random numbers x and y, you have to calculate r. Actually r is radius of the circle. Okay, so that is equal to square root of x square plus y square. I think you know the equation of circle, x square plus y square is equal to r square. So this is the, actually I modified the equation of circle to get this form. Okay, r is equal to square root of this sqrt means square root, okay, of x square plus y square. And after calculating this, we check r, whether r is less than or equal to 1 or not. Okay, you can also use here equal to as well, but let's let it be less than 1. Okay, if r is less than 1 or equal to 1, then pi is equal to, actually it is r, to lie the point fully inside the circle, it should be less than 1. Okay, so pi is equal to, why it is 1? Because we have used unit circle. Unit circle means the diameter of the circle is 1. Okay, so the radius should be less than 1. This one, half of the 1 is half actually, so radius should be less than 1. So we have used this condition. Okay, pi is equal to 4 times number of xy pairs in the inside the circle. Okay, xy pairs means point. Okay, number of points inside the circle. So points are denoted by pair of this x and y. And now pi is equal to 4 times number of xy pairs inside the circle divided by number of xy pairs inside the square. Okay, I have mistake here. And then after calculating the value of pi, terminate the program, and we simply run the program to display the output, and we get pi is equal to 3.14159 and so on. Let's see what will be the value of in these dots spaces. Okay, we perform this simulation in fortran 90 as well. Okay, so this is the simple theory about Monte Carlo simulation to estimate the value of pi, and you have considered the points inside here. Okay, inside the circle as well as inside the square. Okay, we will display the value of the number of points as well inside circle and inside square as well. Okay, so now let's go to the code. Okay, this is simply the theory. Okay, don't worry, I will provide um, if you want to get the this file and the codes, fortran codes as well, please check in the description. There is the link I have provided for you, from where you can get the files. Okay, now let's go to the file. Okay, so this is the method, simple method to estimate the value of pi I have shown before. And now let's go to the actual Monte Carlo method. Okay, so this is the file I have created, because I could show you by typing the codes here, but if I do so, then the video will be too long. Okay, which would be very boring. Okay, so I have prepared this file before, and I am going to explain it to you. Okay, so simply, if you have basic ideas, you must have basic idea about writing the fortran code. Okay, so first of all, we define a program name of the program. I give it the name as value pi. Okay, and implicit none is there, and I have told you I use double precision. I recommend you to use double precision while declaring the variables. Okay, and x y is, I have shown you the x dimension, y dimension. X y are the random variables, and this is the pi we are going to estimate, and this is the real value of pi that I have shown you how to estimate it is simply. So this is the best method of estimating precise value, so I use this value as the this method as the standard value of pi. Okay, while estimating the errors in the Monte Carlo method. Okay, so real value, I define real pi as variable as well, and error and r is there. Okay, and also define integers and im. I have defined two integers here. Okay, and first write after that, defining all variables and integers, you have to insert the number of points inside the square. So I have told you how many points are there inside the square. Okay, this square, so some of the parts are covered by the circle, and this number of points in this circle will be the iteration of the iteration. Okay, or repetition while using the condition. Okay, so we have to define that number of points before, and based on the, if this value is high, then you will get more precise value of pi. So it says to insert the value, and if you write some number and press enter, then program reads the value that you have provided. And I have defined here real value of pi as this. Okay, I have shown you in here. Okay, and now we have to generate the random numbers. Okay, for this we call simply srand, and this is the seed. Okay, you can use the any value, integer values, large integer values. Okay, so I have used here 1 to 9. Okay, and after calling the srand, we use do loop here. So how do loop works? Do loop works from I to n. N means the number of iteration or number of points we have provided for in the square. Okay, so I runs from 1 to n, and according to the value of n, the program will generate the pair of the x and y. Okay, so pair of or the program will generate n pairs of x and y, which is random number. Okay, and after generating the x and y as random numbers, we simply calculate r is equal to x square plus y square. I have shown you in the algorithm here. Okay, this condition. Okay, I just use here r is equal to x square plus y square, so we will use it as here. Okay, so it must be actually sqrt. Okay, it must be sqrt actually. Okay, now if r is less than 1, so I have used double precision, so 1 dot d0. Okay, then now we are going to, using if condition, we are going to estimate the number of points inside the circle. Okay, so how it calculates, there is the condition. Okay, this value should be less than or equal to 1, so m is equal to m plus 1, pi must be then after defining value of m, pi must be 4 times real m by real I. Real m means so m is actually integer, so we have to define it as real, so I define here real. Okay, and this whole number is the number of points that lies inside the circle, and this is the number of points that lie inside the square. So this ratio multiplied by this value 4 gives you value of pi. Okay, and if n do. Okay, this formula estimates the value of pi by Monte Carlo method. And to calculate the error is defined by absolute value of abs absolute value of real pi minus I, the value of pi estimated from here. Okay, divided by real pi, so I estimate error as percentage, so simply multiplied by 100 here, and the output will be number of the points inside the m. Okay, how many, so number of points inside the square will be this n. Okay, which we have to provide, and the program will display calculate the number of points inside the circle as well, and estimated value of the pi p, and real value of pi real pi, and the error as well. Okay, error in the method means error in the Monte Carlo method. Okay, this completes the program. Let's save it once more, and to run it we have to open the terminal in the same folder where we have saved the file. Okay, so now let's run the program. Okay, zip fortran, and what we have given the name of the file, it is emc.integer enter pi value. Okay, so let's type this name emc int. Okay, emc underscore enter, and this is the value name of total file. Okay, the program is correct. Now let's see the output. Okay, to see the output you have to provide the number of points inside the square, which is also the number of iterations. Okay, the higher the value of points of the number of points of the points inside the square, the more precise will be the value of pi. Okay, so let's say it be for simplicity, let's it be 10 first. See, if you provide number of points inside the square as 10, there will be 10 pairs of xy. Okay, it means the 10 points inside the square. And how much points will be in the inside the circle? There will be 9. Okay, and this gives estimated value of pi. This value is the value of pi estimated by the Monte Carlo method, and it gives 3.599. okay, and this is the real value, and this is the percentage error. Okay, Now let's calculate for 100 again. Okay, and this is the number of points inside the square, this is number of points inside the circle, and this is the estimated value of pi. See, as this number increases, it approaches close to this value. Okay, see the difference here and here. Okay, again let's provide 1000 here. Okay, and let's see the error. Okay, for 1000 number of points inside the square, there will be 785 points inside the circle, and it gives value of pi as this, and error in the calculation is this. Okay, see the error is decreasing as well. Okay, here is 14%, here is 5%, and here is 5 into 10 to the minus 2%. Okay, now again let's provide 10,000. Okay, 10,000. If you provide the value of number of point inside the square at 10,000, then see. Okay, this is how we can calculate the value of, or we can estimate the value of pi. Do not use calculate, because there is a difference between estimating and calculating value. If you exactly know the value, and the process, the method calculates or gives you the value, actual value or real value, then you can say it as calculating the value. Okay, if it just gives you approximate value, then it will be estimation. Okay, so Monte Carlo method estimates the value of pi, not calculates the value of pi. There will be different, so be careful. Okay, this is how you can estimate the value of pi using Monte Carlo method. Okay, there are two you can use the Monte Carlo method in two ways. Okay, I have shown you, this is one of the way. Okay, and there is another code file I have created. Okay, this is this one, and it uses the random number in a different way. Okay, so this is also same. Actually theory is same. Okay, theory is same, algorithm same, but the way of writing the code is different. And here we define double precision side, and this is xy random numbers. Okay, this is side of the square, and r means here to define the random numbers. Okay, and radius of circle, area of square, points inside the square, points that lie inside the square, points those lie inside the circle. Okay, and double precision again, distance from the origin. So here we define distance of the point, xy point from the origin. Okay, an approximate value of pi, the pi value of pi that we estimate from this method. Okay, which is defined as approximate value, approx pi. Okay, and real pi as we have defined before, and obviously the error. Okay, and here we define integers only n and iteration. Iterations means you will see in later. Okay, so print higher the value of iteration, higher will be the accuracy of estimated value of pi. Okay, higher the value of iteration, more closes the value of pi to the real value. Okay, and we have to provide the enter the number of iterations. Okay, and the program reads iteration number you provided, and as you know, the each side of the square is 1, so side is 1 here. Okay, and the radius of the circle is half of the side. Okay, because diameter of the circle equals the side of the square, so radius is obviously half. I define radius as this. Okay, area of circle, and you know area of area of square. Okay, area of square is equal to side multiplied by side. Okay, which is square of the side, and it is written as this. So first of all, what we define is, let's suppose the points inside, initially the point inside the square is 0 and points inside the circle is 0 as well. Okay, now we use do while loop here to define the estimate the number of points inside the square and those inside the circle. Okay, so first of all, let's define n is equal to 0. Okay, actually n will be the number of points, actually number of points inside the what estimating value of pi, number of points inside the actually it is easy inside the square. Okay, it is actually point of number of points inside the square, and it will be the value as you provided here, iteration. Okay, now so under do while loop, which is n is less than iteration. Okay, n, this condition do while will be applied if n is less than iteration. Okay, so call random number. The way of defining random number is different here. Random number as r. Okay, r is actually random number. Okay, and x, random number x is equal to side by minus side by divided by 2 plus side multiplied by r, and similarly random number y is defined as this. Okay, and after defining the random numbers x and y, the distance of xy is xy from origin is defined as this. Okay, given is this. And to check whether the points lie within the circle, what we do is, if distance from the origin is less than or equal to radius square of the radius. Okay, then what we define, points inside the circle is equal to points inside the circle plus 1, and as we have used here the do while loop, it goes on increasing by 1. Okay, if you do not have any idea about using do while loop, please click on that I button. Okay, there is, I have provided the video link which is about the do while, continue, do, go to, and loops, etc. Okay, you can watch that video as well. So this step gives the points inside the circle, and after this step gives the points inside the square, and this step estimates the value of pi. Okay, with this formula. So formula is same. Okay, and n is equal to n plus 1 as well. This gives the number of points inside the square as well. Okay, so so here I have written print r. Actually r is random number, so we don't, and random number we don't need to print it. Okay, so this step prints the value of approximated pi. Okay, and this gives points inside the circle, this gives points inside the square, and for error calculation we have defined real pi as this. Okay, and error is defined by this. Okay, and these two steps gives you value of pi and the error in calculation. Let's run this program as well, see the name of the file. Okay, now let's run. To run this, let's go to the this folder. Okay, I have saved all files here, so open the terminal again and let's run that file. Okay, what was the name of the file? It is emc Monte Carlo pi value. Okay, so emc underscore pi. Okay, it gives like this. Okay, now run it, enter the number of iterations you want. See, let's check it first with 10. Okay, You see, this is the value of I, okay, R, which is a random number that lies between 0 to 1. You can actually, the value of R must be 10. Number of values of R must be 10, okay. I have used the printed the R after do loop, okay. If you use before do loop, then it will print up to 10 values, okay. So this is the estimated value of pi, okay. It is 2.799 and so on, which is very less than actual value. Number of points inside circle is this, okay, and number of points inside square is this. You see, this is equal to the number of iteration, okay. And real value of pi I have defined is this. So this value is very less than this, okay, and this is the error, which is 10%. So let's check it with another number of iteration, so that it be 100. Now see, value goes near to this value, okay, and number of points inside circle is 81, and number of points inside the square is 100 as well as it is, and error in calculation is 3 point something. See, here is 10 error, but here is 3%. Let's again check with another value, okay. So here is I have used 100. Now let's check for 1000, okay. See, for 1000 the value is almost equal, okay. See, for double precision it long values there are, and this is the points inside circle, points inside square, and this is the error percentage error, okay. See, now it is 0.718. Now again check with the higher value. Now let it be 10,000, okay, 10,000. See, the error is nearly 3 into 10 to the power minus 2. It is 0.003, okay. Before it was this, and now it is for 1000 it is this. Now let's check it again for, I have used 10,000. now it be 100,000, okay, 100,000. So it is this, okay. Again for 1 million, let it be 1 10 100,000 10,000 100,000 million, okay. For millions, see the value of pi. See, now it is almost equal, okay, 4.2. and if you check it in the calculator, the value will be, what will be the value of pi? This is pi, okay. If you click here, then the value of pi will be up to this, okay. So it uses the single precision, and it is only up to this, okay. But here it gives so long, many digits. So this is how you can estimate the value of pi by using Monte Carlo method in Fortran programming language, okay. I think video is has been so long, okay. Thank you for watching this video. Please get the file by clicking the link in the description. Thank you for watching. See you in the next video, okay.